So Amber's joining us from her holiday in Albania, and she's doing this on data since her hotel doesn't have Wi-Fi. So she might be a little bit more pixely or out of sync or breaking up on occasion, but we think the connection's pretty good. But if there's something that you miss or didn't hear, or things suddenly go haywire, please go ahead and chime in. And if we lose her or something goes, totally wrong, then we'll wrap things up and we'll pick up where we left off next time. Okay. So Amber, feel free to take it away. I'll pin you up there and then I'll be quiet.
Okay, I will share my screen. Okay, so I hope you can hear me okay. If you can't, please just let me know. I can't actually see any of you at the moment, so if you are struggling to hear me or if I just disappear or anything, I do apologize. But yeah, as Robin said, I am using data, so I just hope this will work. So my plan for today is to quickly review last week. I did give some of you a task. If you were here, or 2 weeks ago, if you were here in the lesson, I gave you a task of 10 questions on indices. So I'm going to go through those with you. And then we're going to complete Unit 5, looking at surds, both simplifying surds and basic rationalizing the denominator. Later on in the year, we will come back and look at a more advanced version of rationalizing the denominator, but I'd like to do more algebra with you in the future first before doing so. And then we'll move on to Unit 8 and we'll look at some percentages, specifically percentage increase and decrease and reverse percentages using a calculator. So this last section will be using calculators. If you've got a calculator handy, this is the one I use, something similar to this. Please do grab it now. If you don't, doesn't matter, because we're going to look mainly at the method rather than the actual doing of the calculation. So don't worry too much, okay? So let's start then. So this is the challenge that I asked Robin to put into the forum, and I don't know if many of you have had a chance to have a go. But this is based on those laws of indices that we learned 2 weeks ago. So we had the 5 sort of basic ones, just using those laws of indices here. And then some of you wanted to have a go at some challenges. So I've given you the challenges on this side here. And if anyone wants to be brave and shout out or write in the chat, or even if you can write on the screen what you think the answer to the first one is, please feel free to have a go. I'm going to get the chat up so I can see if anyone. Okay, so we've got excellent. Yeah, fantastic. Well done, 70. Yeah, so we've got it's going to be 2 here, 2 to the power of -1. Why is that not clicking up then? There we go. Okay, because this is the power of addition. Okay, so we're going to do 3. Sorry, this is the law of addition. So we're going to do 3 and then take away the 4 there. So it's going to be 2 to the power of 3 minus 4, which is 2 to the power of -1. So the next one then, we've got the division law. So the division is going to be using the law of subtraction there. So again, I will just quickly check the chat. We've got something 5 to the power of 4. Fantastic. Well done. Fantastic. Well done. So really good to see some people getting some answers correct. Okay. Then we're going to move on to the law of multiplication, but also including numbers. So we've got numbers to deal with as well as the algebra here. So 2 things to think about. If you want to have a go, please do. Question 3. I'm not seeing any answers in the chat yet. Okay, that's fine. So I'm going to go through the answers. Oh, fantastic. Really good. So we've got 3 times 4, which is 12 there. And then the law of the indices here, we've got a to the power of 3 multiplied by a squared. So that's a times a, but we've got 3 a's here, 2 a's here, so it's going to be a to the power of 5. So it's going to be 12a to the power of 5 here. Okay, so really great to see a couple of people having a go there. Okay, so moving on to the law of brackets. Now this one was the one, because we've got the brackets here, we've actually got 5 lots of this x cubed. So it's going to be x to the power of 3 multiplied by 5 here. So it's going to be x to the power of 15 here. And then finally, and this is the one which a lot of people are fantastic, seeing some correct answers again. This is the one a lot of people do tend to forget. So I just want to highlight this again. It's very easy to forget about this number inside the brackets here. So we've got a 2 inside the brackets. So it's 2 to the power of 3, as well as y squared to the power of 3. So that's going to be 2 to the power of 3 is 8. And then y squared to the power of 3 is y to the power of 6. 2 times 3 there is 6. So it's going to be 8 times y to the power of 6. So that's really great to see some people giving me some correct answers there. Well done for having a go. I'm just going to quickly run through the answers for this one on the challenges. A bit more complicated, but very much exactly using the same laws. It's just that you need to apply them a few times here. For example, you've got a bracket law, then you've got the law of multiplication, and then you've got the law of division. So quite a lot to do with this one. So the answer to question 6 was 2b. So if you did have a go, just have a check your answers now. Okay, so it's 2b squared, which is going to be 4b squared there, times that by 3b squared, so that's going to be 12b to the power of 4, and then divide by 6b cubed. Question 7, then we had to do the law of brackets and the law of addition or multiplication there. So that's going to be 8a cubed times that by 2b to the power of 4. Notice here that the a and the b, they cannot be joined up in any way, so they have to be dealt with separately. So we've got 16a cubed times b to the power of 4 there. And moving on to question 8, we've got a to the power of 6, b to the power of 6. So that's a to the 6 times b to the 6. Dividing then by b squared, so that's going to be a to the power of 6 times b to the power of 4, because we're going to subtract those powers. Question 9, we're going to go 2 times 4 is 8, and you'll see the numbers actually cancel out. 2 times 4 is 8, and they cancel out with this 8 on the bottom of the fraction there, okay? Just noticed I've got a few things coming up in the chat. Great. Sorry, I'm probably going a bit fast now, but I don't want to spend too long on this because this was sort of last lesson's work. So we've got 8 divided by 8 there, so that's a 1. So the numbers cancel out completely. The x's then, we've got x to the power of 3 multiplied by x to the power of minus 2, so that's x to the power of minus 1. And dividing that then by x to the power of 4, so that's x to the power of minus 5. Is it? No, sorry, x to the power of 3 multiplied by x to the power of minus 2 is x to the power of 1. Dividing that then by x to the power of 4 is x to the power of minus 3. And that could also be written, if any of you know, or if you remember our law of the reciprocals that we did last session, as 1 over x to the power of 3. And then finally, question 10, we've got 2x, and we're going to square all of that. So we must remember that this 2 is squared as well. So that's 4x squared there, times that by 6y to the power of 5. So that's going to be 24x squared y to the power of 5. Dividing that by 6, 24 divided by 6 is 4. The x squared will divide with the x, so that's just going to be an x. And the y to the 5 will divide by y cubed, so that's going to be y squared. So we've got 4xy squared. So those last 5 there, they were quite tricky. They were your kind of higher level challenge ones. But if you did get those correct, then well done. Or if you sort of didn't get some right, or if you made some mistakes, but you can now see why, that's really great to see as well. So I hope that's helped. Anyone got any questions before I move on? Please do let me know. I can't see any of you, but please feel free to. Okay. I can't see anyone raising their hand, so I'm just going to move on then. So, okay. So unit 5, we didn't quite get onto surds. So what is a surd? That's a question that quite often gets asked, and it's quite a tricky thing to answer, really. But it's in the simplest term, it's just if n is a positive integer, so if it's a whole number that's a positive number, and it's not a square number, then the square root of n, root n, is a surd. Okay, so for example, root 5 is a surd because 5 is a positive number, it's a whole number, and it's not a square number. All right. So root 5 is a surd there. The square root of 10 is also a surd. 10 is not a square number, so that's a surd. Square root of 4 is not a surd, okay, because the square root of 4 is a square number. The square root of 4 is 2, so that's not a surd. And the square root of 0.5 is not a third either, because that is also not a whole number. So it's not a square number, but it's not a whole number. I've just seen a question here. 4xy to the power 4, 4xy squared. Do you want me to just go back a moment? Sorry, you did ask a question. Let me. Robin, I'm not sure why, but I can't see anyone's videos. I don't know if it's because you've pinned me.
Yeah, it is. For you, if you go up in the top right corner where it says view, do you see on your screen?
No.
Oh, actually, you know what? It's because you're presenting as well. Hit your escape key and see if you. No, that doesn't help, does it? Nope, sorry, go back. Sorry about that. Sorry,
Okay,
everybody.
let's do that again. So I'm actually going to go back. That's okay. I don't think I need to see videos. Semsi asked a question. I just wanted to know.
Yeah, don't worry, Semsi. No, you don't need to apologize. What you need to do is, I'm just trying to think in presenter view where it is. You can change your view to gallery. Oh, it might be on the top left where there's a little grid of boxes or something.
Yeah. Okay, that's okay. I can see the question now. So is this question 10 here? So we've got, can you see question 10 is on the screen now? Yeah.
Yeah.
So we've got 2 squared times, so 2 squared times x is 4. So I think the question was about the, the y part, because you have y to the power of 4 and I had y squared. So let's have a look. Y to the power of 5 here. Oh, I think you might be right. Hang on a minute. Yeah, so y to the power of 5 here, and we're going to divide that by y to the power of 3. So that's actually just going to be y to the power of 5 minus 3 there. So it's y squared. Does that answer your question? I wonder if that was the question. Okay. Yeah. Okay, great. Yeah. No, thank you for asking. Any other questions about these, please do ask, because obviously I can't see your faces today, so I can't see whether or not you're sort of smiling and following along or not. So please feel free to just write in the chat if you have any questions, okay? Okay, right. So going back to our surds, I'm going to just play a little game. It's not the most exciting of games, I'm afraid. It's called surd or not. So I'm just going to see whether or not you got what a surd actually is. So I'm going to open a poll. And I'm going to put a few, either there'll be a surd or there won't be a surd. And I'm going to ask you to decide. So let's go for it. So we have the square root of 2 here. So I should now be launching a poll. Okay, hopefully you can see a poll in front of you now. You can choose between either a surd or not a surd. Not seeing any. Robin, has it come up? I'm not seeing any answers.
Yeah.
Oh yeah. Okay, we've got one. Excellent. So if you think it's a surd, click on surd. And if you think it's not a surd, click on not a surd. So remember, a square is a positive whole number. Sorry, a surd is a positive whole number, but not a square number. Okay.
So we got 3 of 5 people.
So we've got 3 people. It doesn't matter. Some people might be unsure. So should I end it there?
Yeah.
Yeah. Okay. Okay, so I will end that. Share results. Everything's a little bit slow today on my computer, so okay, so we have got the 2/3 correct answers. So let's just have a look. So this one here is a whole number, so that's correct, but it's not a square number. So this one is not a surd. Okay, so sorry, this one is a surd because it's a whole number, but it's not a square number. A surd has to be a positive integer, but not a square number. Square numbers are, just a quick reminder, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Okay, so it is really important for both foundation and higher students that you know all of your square numbers up to at least 12 squared, which is 144. And this is one of the reasons why it's really important, because you have to be able to recognize kind of instantly whether or not a number is a square number. So it's very, very just really important just to learn those numbers. Just think, like, roll them off every now and then. 1, 4, 9, 16, 25. Make sure you know them, because if you don't know them, something like this is going to be a bit of a challenge. Okay, so let's try another one. Square root of 9. Okay, so think about your square numbers. And then I'm going to launch that poll. Did I not share the results last time? No, I just need to do that. Relaunch the poll. Continue. Okay, you should be able to vote now. Or is it a surd or is it not a surd? We've got one answer coming in already. A couple of answers come in. So it is a surd if it's not a square number. It's a bit hard. I don't know if my computer's just a bit slow with me. Okay. All right, so I'm going to end that poll. And we've got a 50-50 there, so I'm just going to go through it again quickly. So this one is a whole number, but it's also a square number. So this actually, we can work this out. Square root of 9 is actually the number 3, okay? So it's not a surd. If you can find a whole number from it, the square root of 9 is 3, then it's not a surd. A surd is only a square root of a non-square number, okay? All right, let's try this one. So we've got 2/3, so the square root of 2/3. Let's relaunch that poll. Here we go, have a go. Is it a surd or is it not a surd? Think about positive integer. Oh. Okay, so integer means a whole number. So a surd has to be the square root of a whole number, okay? So that one is actually not a surd because it has to be a whole number there. So if it's a fraction inside that square root, then no, it is not a surd, okay? Even though it's not a square number, 2 is not a square number, 3 is not a square number. So the square root of 2 is a surd, the square root of 3 is a surd, but as a fraction, not a surd, okay? Has to be a whole number. So they're a bit tricky, this one. Let's try another one. Square root of 11. Is it a surd or is it not a surd? So I think it's got to be a positive integer, but not a square number. I'm going to relaunch that poll now. Square root of 11, surd or not a surd? All right. Okay, so we've got 3. Okay, I think so, yeah. I think some people are maybe not able to participate. Does everyone know how to participate in the polls? I think if anyone's struggling, please do let me know. Okay, so we have got 2/3 correct answer that time. So it is a whole number, so that's a yes, and it is not a square number. So yes, this one is a surd, all right? Square root of 64. Have a think about this number. Have a think about the square root of 64, and I'm going to relaunch that poll. Seeing some correct answers coming in. Okay, all right, so again, 2/3 correct. This one is not a surd because the number 64 is 8 times 8. 8 times 8, 8 squared is 64. So the square root of 64 is 8, all right? So not a surd there, okay? So here we've got the square root of 0.36. Think about the rules. A surd has to be a whole number, a positive integer, but not a square number. Let's have a go. Fantastic. Okay. Okay, all right, so just having a look at that one then. Not a surd again, okay, because this time it is not a whole number, so it had to be a whole number. Had it been the square root of the number 36, it would have been not a third as well, because that's a square number. So this is not a square number. Square root of 0.36 is not a whole number, so it's not a third. And I think this might be the last one. Oh, sorry. Oh, well, I think I accidentally just gave you the answer there. But yeah, that one is a third because it's not a square number. So it's a whole number, not a square number. Here's the last one, square root of -3. It has to be a positive integer, but not a square number. Let's relaunch this poll one more time. Great, really quick answers that time. All right, I think that's the 3 people that are participating done. Okay, so let's just have a quick look at that one then. And that one again is not a third because we've got a negative number there, okay? And in fact, if you do have your calculator on you, it's always worth just typing in something like that. If you type in the square root of -3 into your calculator, you'll probably notice, unless you've got a graphics calculator, that you will get an error message. So if you get an error message, that's actually correct. You should be getting an error message. And the reason why that is because any square number or any number that we square, we're always going to get positive. So if we take the number 1 or 2 or 3 and we square it, we'll get 1 or 4 or 9. And also if we take the number -1 or -2, we'll square and we square that. -1 times -1 is just 1. -2 times -2 is just 4, okay? So if we square a negative number, we actually get a positive number as well. And because of that reason, we cannot then take the square root of a negative number. So that's actually why we get those error messages on our calculator. It's actually correct. And if you have a really high-tech graphics calculator, you may find that your answer will give you what's called a complex number or an imaginary number where you get the letter I. And that's something that mathematicians use to kind of, it's almost like extending the number system in a higher level mathematics, where they decided that a 2D number system wasn't enough, so they started using third dimension of numbers. And they call them imaginary numbers when they take the square root of a negative number. So that's something completely separate. We don't have to do that in GCSE, but that is why you get that error message on your calculator. So before I move on, does anyone have any questions about what a surd actually is? Or do we kind of have an idea now? It has to be a positive number, but it cannot be a square number. That's the rule. Does anyone have any questions there they'd like to ask? Please do unmute yourself if you want to, or pop it in the chat. No? Okay. Okay, so one of the things that you would have to do on a non-calculator paper at GCSE level is simplify a surd, okay? Your calculator will actually do this for you. So you can do this on your calculator, no problem. But if you are on a non-calculator paper, you have to be able to do this yourself. So this is something I want to spend a bit of time talking about. For example, the square root of 45 is a surd, but it's not in its simplest form. We know it's a surd because it's a positive number and it's not a square number, okay? But it's actually not in its simplest form. And the reason why that is because it has a factor that is a square number. The factor is a number that goes into another number. So the number 9 actually goes into the number 45 there, okay? So we can look at, because we know that it's got a square number that is a factor, we can break 45 down into those 2 square numbers. The square root of 45 is exactly the same as the square root of 9 times, that should say the square root of 5 there. I'm very sorry, because 9 times 5 is the, oh, I've lost it. Sorry. There it is. That should, I'm going to correct that because that's not right. There we go. Let's just do that again. So 9 times 5 is 45, okay? So we can take that square root of 9 there and we can actually just work out what that is. And we should know that the square root of 9 is 3. So the root 45 is actually 3 multiplied by root 5. And you can write that like this. So that's the roots of the surd 45 written in its simplest form there, okay? If you were to do this on your calculator, if you have one of these in front of you, and you actually type in the square root, which is Hopefully you know where the square root button is. It's on my calculator. It's in the second row down under that calc sign and 1 in. If you type in the square root of 45, it will simplify that to 3 root 5 for you. So this is a non-calculator paper topic. Okay. So what you have to do is when you want to simplify surds, you need to look for factors which are square numbers. So let's have a go at doing that now. So the square root of 12, okay, 12 is root 12 is a surd. 12 is not a square number in itself, but it does have a factor that is a square number. Hope I'll let you have a think. And hopefully you thought about the number 4. 4 is a square number. So 12 can actually be written as the square root of 4 times 3, which can be then broken up into the square root of 4 multiplied by the square root of 3. And then that can be written as 2 root 3. So to simplify root 12, we would write it as 2 root 3 there. Okay. So I'm going to give you a moment just to have a think about this one. Think about what the square number is that could go into the number 18 there. Okay, so hopefully you've thought about the number 9. So 18 can be written as 9 times 2. We can then split that into the 2 separate surds there, root 9 times root 2. Root 9 in itself is not a surd because we can then calculate that as 3 root 2. Root 9 is 3 and the square root of 2 is a surd, so it cannot be simplified any further. Let's have a go with the square root of 8. What square number is a factor of the square root of 8? Okay. So again, we've got the number 4 here. So 4 times 2, 8 is 4 times 2. Simplifying that, we've got the square root of 4 times by the square root of 2. And then that should say 2 root 2. I'm so sorry, there's lots of mistakes in this one today. That should say 2 root 2. The square root of 4 is 2 multiplied by root 2 there. Okay. Okay, so another hint is when you've got a third that's a much bigger number, for example, root 72, there's actually a few square numbers that could go into the number 72. There's quite a few factors of 72, so 36, 4, 9 all go into 72 there. So if you want to simplify a surd quickly, just look for the biggest square number that goes into 72 and simplify that way. So if we were to break 72 down into 36 multiplied by 2, and then we can take the square root of 36 and the square root of 2, and the square root of 36 is not a surd because that's just 6, and the square root of 2 is a surd, so we've got 6 root 2 there. Okay. So here we go again. We've got another quite big number here. We need lots of square factors, square number factors in there. So we need to think about the biggest number that is a square number and a factor there. Really important square numbers for this spec, isn't it? So the biggest square number factor that has is the number 100. Okay, so 100 times 3, and the square root of 100 is 10. And the square root of 3, well, that's a surd, that's 10 root 3 there. And let's just do one more. So we've got root 48. So again, quite a few square number factors here. 4 goes into it. Okay, 16. So what's the biggest square number factor there? And that one is 16. Okay, so 16 goes into 48 3 times. So that can be broken down into 16 times 3. And then we have the square root of 16 multiplied by the square root of 3, which is 4 root 3. Okay, so anyone got any questions? I'll just check the chat. Nothing in the chat there. So what I'm going to do is just put, I've got a few have a go questions here. What I might do is I might skip this slide for now, and then I might once again get Robin to put those questions into the forum. And you can have a go in your own time, so it can be like another little homework for you. If that's okay with you, Robin? I think she's there. Hopefully. Okay, so hopefully, yeah, we can pop those into the forum for you and you can have a go at doing that. quickly skip through those. Okay.
I'm here. I was
so
trying
let's
to
have
do
a
a
look at.
thumbs up for you, and I
Oh,
failed.
sorry.
So I am here listening. I'm just leaving it to you. I will do that. No problem.
Okay, great. Thank you. Yeah, I can't actually see anyone, so it's hard to know if anyone's sort of giving me thumbs up or hands up or anything, but I'm hoping that someone will
It's
shout
okay.
at me if they have any questions.
You're on your laptop. You don't have your extended screen. I'm sorry, I can't. There is a way for you to see it, but I just can't remember in presenter view how to tell you to do it. So
That's fine. Yeah, that's okay. All right, so let's have a look at an exam question. This is actually a past exam question from a GCSE non-calculator paper, higher level, I think. So we've got simplify the square root of 125 minus the square root of 45, giving your answer in the form a root 5, where a is an integer. So we need to take both of these thirds and we need to simplify them separately. So we're going to take square root of 125 first, and we're going to look for the highest possible factor that is a square number, which is 25 in this case. So 125 is 25 multiplied by 5. 25 square rooted is 5, so that's the same as 5 root 5. Doing the exact same thing with the number 45, so 45 is the same as 9 times 5, and square root of 9 is 3, so we've got 3 root 5 here. So now that we've simplified both of them separately, we can put them back into the original question, which was root 125 minus root 45, which is now going to be written as 5 root 5, take away 3 root 5, and that's going to be 2 root 5 there. Okay, so that's our answer. We've got A. A is an integer, which just means it's a whole number, so that's the number 2. So we know that A is the number 2, and then we were given that it was root 5, so we know that that's probably correct. If you're in an exam, it's quite nice to just know you're probably correct when you're doing a maths exam, so that's quite good. Okay, so moving on then to the second sort of topic I wanted to do from surds, which is rationalizing the denominator, which basically just means getting rid of the surd on the denominator. So if we have something like this, and again, this is a non-calculator topic, because if we did this on a calculator topic and you typed this into your calculator, the calculator would do this maths for you. It would just give you the final answer. So this is something that would come up on a non-calculator paper. And to rationalize the denominator here, you want to get rid of the surd on the bottom of this fraction. And to do that, we actually just multiply it by what's called a special type of 1, okay? And the special type of 1 is going to be whatever the surd on the denominator is, but on both the numerator and the denominator, because that fraction is actually just 1. Square root of 6 divided by the square root of 6 is 1. So by multiplying it by this, we can then change the fraction, so it's exactly the same number, but it doesn't have a surd on the denominator. Okay, for some reason in maths we're not allowed to have a surd on the denominator. It has to be a whole number on the denominator of a fraction. So to do that, we're just going to multiply straight across the top of the fractions. There we've got 2 multiplied by root 6, and straight across the denominators, square root of 6 times by the square root of 6, which is just 6. Okay, times root 6 by root 6, you get 6. Okay, any questions on that? We'll do a couple more. We'll do another one. Okay, oh, and then of course you can simplify that. 2 divided by 6 is just 3, so that fraction can be simplified there. So it's a slightly more tricky topic now, but let's have a go at doing it 1 over root 3. So first of all, we need to think about what we're going to multiply it by. We're going to multiply it by a special type of 1, and that special type of 1 is going to be root 3 divided by root 3. So that's going to be root 3 over root 3 here. Then we're going to multiply these fractions together, which means we just times straight across the top. That's 1 times root 3, and straight across the denominators, that's root 3 times root 3. So we get root 3 over 3. And that one can't be simplified. That one's just in its simplest form already. And I don't think I'm going to do that one right now. I'm going to come back to that later. So let's go back. Okay, so I was going to get you to just to have a couple of minutes to have a go at a few questions yourself. So if you're feeling brave, I know it's not easy to write things in the chat, but if you're feeling brave, please do feel free to have a go or unmute yourself and tell me what you think the answer should be. grab some pen and paper and just have a go. Think first about what you would like to multiply the top and the bottom by, and then do that multiplication and then see what your answer is. If you don't simplify it, don't worry about that at the moment, but you should simplify your answer in your exam. So, anyone want to have a go? Okay, so if you've had a go, that's great. I hope I've given you enough time. So the special kind of one we're going to multiply by is root 3 over root 3 here. Multiplying across the top, we've got 2 times root 3. Multiplying across the bottom, we've got root 3 times root 3, which just becomes 3. And now that one actually can't be simplified at all. It's just 2 root 3 over 3. Okay, 2 over 3 cannot be simplified there. So here's another one for you. Okay, so we've got a surd on the denominator here, times that then by root 6 over root 6. And so that is going to be 3 root 6 over 6, which does simplify to root 6 over 2. And I'm going to, there we go. I'm going to skip through that bit as well. Here we go. Okay. So we will come back to surds and we'll look at those more complicated rationalizing the denominator questions. But I think that's actually a lot easier to understand after we've done some algebra work. So we'll do some algebra first, and then just got a light flashing. Not sure what's happening. Sorry. We'll do some algebra first, and then we'll come back to surds and practice the final topic within that, which is the rationalizing the denominator with more complicated denominators there. Okay. So let's have a look now at Unit 8, percentage increase and decrease, which I wanted to do today as well. So here's a question that we might have to look at. And what I want to be able to do, and I would do, this is going to be calculator topics now, is I want to make sure that you would be able to do this on a calculator paper using a sort of single calculation, because I'm pretty sure most of you would be able to do this using a sort of step-by-step calculation where you find 10%, you find another 10%, you add them together to get 20%, and so on. Sorry, I think maybe the electricity's just gone in my building. Bear with me. If I do disappear, I'm really sorry. I hope I'm going to be here for, hopefully it will come back. Okay, so the value of a house has gone up by 20% in the last year. If the house was worth 150,000 1 year ago, how much is it worth now? Okay, so basically, what is the percentage increase of 150,000 increased by 20%? And how could we do that result in a single calculation? What one calculation would we be able to do? So it's quite important. This is actually really important for when we're looking at things like compound interest, which we will be doing probably next session, and just future topics. So there's quite a lot of topics where this is quite important. And it's what we need to think about is actually how much we originally had, which was 100%. That was the original price of the house. And then we're going to add 20% onto that original price. So we originally started with 100% of the cost, and now we have 120% of the cost. So we've got as 120%, we can find that. Great, yeah, great. Correct answer. Well done, Samty. We can find that by working out 120% as a decimal. Percent means divide by 100. So 120 divided by 100 is 1.2. So 120% as a decimal is 1.2. So to increase a price by 20% using a calculator with just one calculation, we would simply multiply by 1.2. Okay, we want to find 1.2 of the original cost. So yes, you can definitely do 150,000. You could find 10%. You can find another 10%. You can add that on, and you can find that answer that way. But I also want you to just with your calculator type in 150,000 and just multiply that by 1.2, and you'll see that the answer is 180,000. Okay, So it's just a really quick way of getting to the answer there. Okay. And this also works for percentage decrease as well. So this little trick works for if something has been reduced. So for example, the value of a car quite often will decrease. So you might buy a car for £10,000 and then after a year, that cost has decreased by 20%. So let's have a think about the original amount, which was 100%. That's the original 10,000. But how much have I got it now? How much of that 100% is it worth now? Well, it has actually decreased by 20%. So I actually only have 80% of that original cost left. So as I've only got 80% left, great, correct answer again, well done, okay. I'm now going to multiply that by whatever that decimal is of 80%. And we find that in the exact same way. 80% is 80 divided by 100. So that's 0.8. So if I take my £10,000 and I multiply it by 0.8, I'm going to get the answer there. Okay, so the house, 120% of 150,000 was 1.2 times 150,000. The house is worth £180,000, which was correct. I did get a correct answer in the chat there. And then 80% of 10,000, that car, which was reduced by 20%, 0.8 times 10,000, which is 8,000. Okay, so that has been reduced. Now, I'm not going to concentrate so much on the actual calculations. I'm going to concentrate on the method here. So to increase something by 20%, we multiply by 1.2. To decrease something by 20%, we actually need to think we're taking 20% off of that original 100%. I've got 80% left, so that means I'm going to multiply by 0.8. Okay. Let's have a quick look at increase again. Have a go at increasing £50 then by 60%. So I'm going to increase by 60%. So I've got the original 100%. I want to add 60% on. What's my decimal going to be for increasing £50 by 60%? What am I going to multiply that £50 by? If anyone wants to have a guess, write in the chat what they think that decimal would be, what they multiply 50 by. Excellent, well done. Yeah, so we're going to multiply it by 1.6. Great. Okay, so 1.6 times 50, which turns out to be £80, okay? If I want to increase £86 by 7%, and this is where you've got to be super careful, because 7% is, lots of people are going to go, 1.7 here. Have a think about what that should be. What should that decimal be? Excellent, well done. Yeah, 1.07. I've just noticed someone's written 30 in the chat there, which is technically correct because 60% of £50 is 30. But don't forget to add that on. If you're going to do it that way, you need to add it on. So by multiplying by 1.6, you get straight to the answer rather than having to go through the finding 60% of 50 and adding it. We can simply go straight to the final answer in one single calculation. So to increase £86 by 7%, we're going to have to find 107% of £86, which is 1.07 times 86. Which is going to be £92.02. Be careful there, that was an increase one. Just be careful not to decrease it. I think you might have decreased it there. So 1.07 times 86, £92.02. So again, this one would have been a lot more complicated if you had to say find 1% and then times it by 7 and then add that on. It's going to be quite a lot to do. Whereas with a calculator, on a calculator paper, you can do this very quickly, just times by 1.07. And yeah, great. And very, very useful trick when it comes to doing repeated percentages and reverse percentages. Knowing how to do this is going to be really important for those new topics, which we'll be looking at later. Okay. Yeah. Okay. So now some decrease questions, percentage decrease. So we're going to decrease £65 by 20%. How are we going to decrease £65 by 20%? So Remember, this time we're going to go down in cost, and I want you to do it in one single calculation. So there should be one single number multiplier you can multiply £65 by. Started with 100% and I'm taking 20% off. What's that going to be? 0.8, fantastic, really great, well done. So 65 times 80% is the same as 65 times 0.8, which is £52. And to decrease £320 by 3%, there's a little hint there if you want to have a guess or write it in. Be careful because we need to subtract that 3 from the 100%. So do you want to have another go? We're going to decrease by 3%. So what will we be left with? We'll be left with 97%. What's that? Yeah, perfect. So 0.97. Great. So we're going to then type into a calculator 320 multiplied by 0.97. And that would tell us then that it's £310.40. So really important that you know how to use those multipliers. And I've actually got one of our ABCD multiple choice questions just for you to have a go at increasing and decreasing using a multiplier. So question 1, what multiplier would you use to increase something by 10%? I'm going to give you a moment just to have a look. We're increasing by 10%. I don't know what the number is. I'm not worried about that. I'm worried more about the method. What multiplier would increase by 10%? I'm going to launch a poll now. And okay, so we want to increase by 10%. We have got a couple of people have answered decreasing by 10%, which would be 0.9, but 0.9 will decrease by 10%. And some people have given me 0.1 or 0.10 here, which would actually give me 10% of the number, but it wouldn't increase. To increase, we need 1.1. So the answer there was actually A. Okay, so a few incorrect answers there, but hopefully we can improve that. So to decrease by 10%, actually some people I think made this mistake in the last one and actually gave me the right answer last time. So to decrease by 10%, we started with 100% and we want to take 10% off. Okay, so how many percent would we have left? And then convert that to a decimal. So have a think. I'm going to relaunch the poll. So we're starting with 100%, we're decreasing by 10%, and then we need to convert that to a decimal. Amazing. Okay, we've got lots of correct answers very quickly this time, so that's really positive. I'm going to just wait to see if anyone else wants to answer. Okay, I'll end that there. And we've got 100% correct answers this time, so fantastic, really great job. The answer this time was 0.9. So we're reducing something by 10%. Okay, we'll have 90% left. And then turning that into a decimal, we've got 0.9. So great. Okay, so it's increase again. We've got the word increase. We want to increase by 20%. So we start with 100%. Increasing by 20%, what would that be as a decimal? Oh, I need to launch the poll, sorry. Okay. Don't forget to increase it. So a lot of you have given me the 0.2, but we need to actually add that on to the 1, okay? To increase by 20%, we're going to multiply by 1.2. So for a split answer there, I've got some people giving me 0.2 and some people giving me 1.2. And the correct answer is 1.2. And the reason why is because 0.2 will give me that 20%, but it won't give me that full 120%. If I want to increase by 20%, I need 120% of the full amount, okay? So I need to think, what's 120% as a decimal? So let's have another go to decrease something by 20%. So to decrease something by 20%, I'm starting with 100% and I want to reduce it. I want to take 20% off. What have I got left? Decrease seems to be easier. I think people are getting that quicker. And really good. Yeah, well done. Lots of people are giving me, everyone's giving me the correct answer this time, 0.8. Well done. Okay. Yeah. So really good. So to decrease, I think decreasing, you understand. 0.8, we're going to start with 100% and we're going to reduce that by 20%. So we'll do another increase one. So this time I'm starting with 100% and I actually want to increase the amount by 65%. So if I'm starting with 100% and increasing it by 65%, I'm going to have 165% of my original amount. So what's 165% going to be of my original amount as a decimal there? Great. So that's 4 people answered. So that's great. Someone else is joining in as well. Excellent. Okay, great. So yeah, 75% correct there. So this time is going to be a 1.65. 165% divide, percent means divide by 100, so that's 1.65. So if I want to increase something by 65, I think I forget to share the results. There we go. If I want to increase something by 65%, I can simply multiply that number by 1.65. Let's try another one. Let's try, I think we'll skip over decrease because we all know that. We'll try increase by 13%. Let's try increasing by 13%. So I start with the full amount, I start with 100%, and I'm going to increase it by 13%. Here we go, we'll relaunch that poll now. Oh, fantastic. Lots of correct answers coming up straight away. Really great. Good. 4 correct answers, so 100%. Awesome. Really, really happy with that. So I think we are understanding. Fantastic. Well done. Really good. I think these might be. I'm going to skip over this because I would like to move on to reverse percentages. So I want you to see now why this is useful very quickly. And reverse percentages are those ones that everybody just thinks, whoa, I hate these questions. Well, lots of people do. If I purchase a skirt for $21.25, and I purchase it for that much, but it actually has been reduced by 15%, what was the original price? And now these multipliers that we've just learned make these questions super easy. Because the multiplier to reduce something by 15% is to multiply by 0.85. We've just done that. We've just thought, okay, well, if I've got 100% and I take 15% off, I'm going to times by 0.85. So now if I want to go back to my original 100%, if I'm like, oh, this originally cost something, but it's been reduced by 15%, now it's 21.25. Well, all I need to do is the opposite of multiplying by 0.85. So all we have to do is divide by 0.85, and that will take us back up to that original 100%. Okay, so how much was that skirt originally? Does anyone want to have a go? Pop it in the chat if you want to. Nothing coming up in the chat yet. I don't know if you have calculators. You might not have calculators. Definitely a question for a calculator paper, this one. So that skirt is going to be 21.25 divided by 0.85, and that's actually $25. Okay, so that's going to take you back up to the original price. So I'm just going to do a couple because we are actually almost out of time, so I'm just going to do a couple of these. So if we want to increase, if we want to find the original price after increasing something by 10%, what would we need to do here? So the multiplier to increase 100 by 10% is actually 1.1. to multiply. Oh, we need to launch the poll. I might actually save this for next time because we're running out of time and I'd rather do this properly than rush through it. So is that okay if I save this for next time and we stop there? I'm just thinking.
Yeah, I think that's good.
Yeah, I'm just thinking there might be some
Any
questions and I've only got a couple of minutes left. So
yeah, in case anyone has any general questions about anything.
yeah. Okay, so I think what we'll do is we'll stop there. Sorry about that. And next time we can start with this reverse percentages topic. Okay.